Good evening. Welcome to the QCIS channel. Where on this channel, you get a daily dose of science, technology, engineering, and math. My name is Leon Jones, and what I'm going to talk about tonight is something that deals with construction, but can actually help you during your everyday life. But the topic is going to be construction cost management. We call it construction project management. Now, why is that important? Well, when you have a project, whether you are a consultant, whether you are a contractor, or you are the client who is a developer or a governmental agency, you have to think about cost. Is the project worth building? Now, when we deal with project cost management, you can basically look at the definition of management. Now, management has a few items. We deal with planning, controlling, coordinating, delegating, communicating. There are a number of issues that we have to deal with, but management deals with not just getting the job done through people, but utilizing costs to complete a project within budget. So you have to add the budget. Now, if you want to be a project manager of a project, whether you are a consultant or whether you are a contractor, it is very important that you understand cost, because with cost, you have to continually track it to make sure you're not over budget. Because as a consultant, what you do is you bill the client. This is why it's very important that if you have employees, they understand the coding system on how to bill a client. And you have to look at your budget, because if you go over budget with a client, guess what that's going to involve? It is going to involve a change order. And a change order actually adds to the original amount of the contract. And when we deal with cost, we try to avoid change orders. Now, if you are a contractor and you're working on a DOT project, you will have some change orders. I've never seen a job without change orders. However, you can still watch your costs, and that cost is going to look at the situation like this. Look at how you're scheduling your activities. Now, let's get into some information while I share the screen, and we'll talk about construction cost management here. We can call it construction project cost management. And that is the process of planning, estimating, budgeting, monitoring, and controlling project expenses from start to finish to ensure that the project stays within its financial limits. Now, the key components include accurate initial estimates, real-time cost tracking, managing change orders. Notice what I said, change orders, and controlling expenditures for materials, labor, and subcontractors. Now, the first one, materials, is a cost, but labor is one of the highest expenses for a contract. And then when you are a general contractor, you have more labor to pay out because you have to pay your subcontractors. So basically, when we deal with project cost management, and you want to make it effective, because effective cost management improves profitability, and it also helps meet project deadlines, and it builds a strong reputation. Now, to understand project cost management, you need to know the key processes. So, there are 5 key processes. And the first one is, of course, planning and estimating. And when you plan and estimate, well, what you have to do is accurately forecast all project costs during the initial design and planning phases. And it's very crucial that you understand and you do that. Then budgeting. And you do this in real life too if you want to maintain money. Well, when you have a budget, what you do, it has to be detailed. So to put everything together, you need to develop a detailed budget based on the cost estimate to serve as a financial target for the project. Then monitoring, very important. This is where quality control comes into place. When you monitor something, when it comes to costs, you're continuously tracking actual costs as they occur, and you're going to compare them to the budget. And when we deal with controlling, you're just taking action to correct variances and you're keeping spending within budget, which includes managing change orders and subcontractors. And then reporting. You have to present cost reports to stakeholders. Again, you have to present cost reports to stakeholders. I said stake owners, stakeholders. Why? To ensure transparency and accountability throughout the project lifestyle. Now, it's very important, and there are benefits to project management, profitability. I'm talking about the benefits, project cost management, but project management is involved because you as a manager need to look at your costs. So going back, we deal with the importance and benefits, we deal with profitability. And profitability helps maintain profit margins by keeping expenses in check and avoiding cost overruns. Because when you have an overrun on a material or you have an overrun on your labor, then here comes a change order. Timeliness minimizes delays that can arise from budget related issues. Again, timeliness minimizes delays that can arise from budget relating issues. Decision making. Well, decision making provides real time data for making informed decisions when unexpected challenges arise. You have your reputation for being proactive, efficient, and reliable with finances, which is a key differentiator in a competitive market. However, there are challenges. There are challenges. Within the challenges, you are going to have some unforeseen expenses and what they are and what they do. Well, what's an unforeseen expense? Well, you could be out in the field, you're ready to build, and you find a UST. What is a UST? I'm just using this as an example, an underground storage tank, which can contaminate the soil. So that's an environmental concern. Well, you didn't know about it, and the designer didn't know about it. So it's going to be a cost to take that tank and try to minimize the contamination from that old tank from the gases, because you could have had a gas station on that site. And even though the gas station has been abandoned for years, there is still some fuel in those tanks that can contaminate the soil. So now you have to get the environmental personnel involved. Some of the soil may be contaminated, so you have to have someone who's probably they have 40-hour HAZWOPER certification. They can sign the manifest. You got to get the contaminated soil off the site. Got to dry it out, aerate it, and you have to store that soil somewhere else because you don't want to bring soil that was removed from a contaminated area back to the site. So that's what an unforeseen expense is. Poor planning. An accurate initial planning and estimation can lead to budget discrepancies, inefficient communication. So lack of collaboration between teams. Again, inefficient communication is a lack of collaboration between teams that can lead to cost overruns. Reason why that happens is somebody isn't watching the materials, the labor, the equipment, and then you have siloed systems. Of course, when it comes to construction, we don't build projects just with manpower, just with paper. We're using computers. So using disconnected software and practices can hinder effective cost tracking. Now, I'm going to get more into this topic with my PowerPoint. And again, I'm a civil engineer, and what I'm going to do is talk about construction project cost management. And cost management is everywhere. If you are a industrial engineering major, you're also going to see this too because you're dealing with inventory, FIFO, LIFO. If you're an accountant, you have to deal with cost, fixed cost, variable cost. You're dealing with labor. So the manufacturing industry deals with this as well. Systems engineering. So you need the proper systems to help you track the cost as well. Now, something you need to ask. Well, what is cost and project cost management? What is cost and project cost management? Well, cost is a resource sacrifice or foregone to achieve a specific objective or something given up in exchange. Costs are usually measured in monetary units like dollars. And then project cost management includes the processes required to ensure that the project is completed within an approved budget. Again, project, when you manage it, to help ensure that the project will be completed within an approved budget. Now, we have the principles, basic principles of cost management. Well, most CEOs and boards know a lot more about finance than IT. So IT project managers must be able to speak their language. So you have to understand what profits are. Well, profits are revenues minus expenses. Then you have life cycle costing, and that is estimating the cost of a project plus the maintenance cost of the products it produces. And you have what we call a cash flow analysis, and that's basically determining the estimated annual cost and benefits for a project. Now, remember this, benefits and costs can be tangible or intangible, direct or indirect. Now, you also have something called a sunken cost. It should not be a criteria in selecting a project. Now, we're going to define some of the costs here so you understand exactly what costs are, because they are broken down, and the different types of different types of costs mean something totally different, but they're all under the umbrella of cost management. So basically, we have tangible costs or benefits, and there are those costs or benefits that an organization or a business can easily measure in dollars. Again, this is important. Tangible costs or benefits are those costs or benefits that an organization or business can easily measure in dollars. Then you have intangible costs or benefits, which are costs or benefits that are difficult to measure in monetary terms. Now, why is that? Because when something is tangible, it's physical. You can pick it up. If something is intangible, it exists like air, but you can't hold it. It's not physical. Then you have direct costs, and they're costs that can be directly related to producing the products and services of the project. Then there are indirect costs, or costs that aren't directly related to the products or services of the project, but are indirectly relating to performing the project. And then you have sunk costs, which is money that has been spent in the past when decided what projects to invest in or continue. Should not include sunk costs. Now, we also have the learning curve theory, and that states that when many items are produced repetitively, the unit cost of those items decreases in a regular pattern as more units are produced. Reserves are dollars included in a cost estimate to mitigate cost risk by allowing for future situations that are difficult to predict. So, under the reserves, you have your contingency reserves, which allow for future situations that may be partially planned for or sometimes called known unknowns and are included in the project cost baseline. Then you have your management reserves, which allow for future situations that are unpredictable. That's future situations that are unpredictable, sometimes called unknown unknowns. Now, in construction, you have different types of costs. So, one of the costs that you always hear about is capital costs. And that's basically expenses related to the initial establishment of the facility. Now, what goes into establishing a facility? Land acquisition, including assembly, holding, and improvement. Then you have planning and feasibility studies, architectural and engineering design, construction, which includes materials, equipment, and labor, field supervision of construction, construction financing, insurance and taxes during construction, owner's general office overhead, equipment and furnishings not included in construction. Then you have inspection and testing. And you have your what we call operating and maintenance costs. We shorten it up and we call it O&M. Well, the operation and maintenance cost is subsequent years over the project life, and that includes the following expenses: land rent, if applicable, operating staff, labor and material for maintenance and repairs, periodic renovations, insurance and taxes, financing costs, utilities, owner's other expenses. So basically, the magnitude of each of these cost components depends on the nature, size, and location of the project, as well as the management organization, among many considerations. So the owner is interested in achieving the lowest possible overall project cost that is consistent with its investment objectives. Then we have our contingencies provisions. So basically, in most construction budgets, there is an allowance for contingencies or unexpected costs occurring during construction. So this contingency amount may be included within each cost item or may be included in a single category of construction contingency. Now, the amount of contingency is based on historical experience and the expected difficulty of a particular construction project. For example, one construction firm makes estimates of the expected cost in 5 different areas. And the areas are design development changes, schedule adjustments, general administration changes such as wage rates. And some jobs have unions, which on those jobs they have prevailing wage. Now you also have different site conditions for those expected. Again, differing site conditions for those expected. In fact, differing site conditions goes on a change order, just as I mentioned that UST that was never discovered as an example that I presented. That's a challenge. That could be an unexpected cost. So again, differing site conditions for those expected and third-party requirements imposed during construction, such as new permits. Now, one thing you need to know about project cost management. Well, it includes the processes involved, as I said earlier, planning, estimating, budgeting, and controlling costs so that the project can be completed within the approved budget. So when we deal with cost estimating, what we're doing is developing an approximation of the cost of the resources needed to complete project activities. And we have cost budgeting. And that's we are aggregating the estimated costs. Again, cost budgeting means we aggregate the estimated cost of individual activities or work packages to establish a cost baseline. And then we deal with cost control. And that is influencing the factors that create cost variances and controlling changes to the project budget. Now we also have tools and techniques. So we have the analogous estimating. That's basically using the actual cost of previous similar projects as the basis for estimating the cost of the current project. So analogous cost estimating uses expert judgment. Analogous cost estimating is frequently used to estimate costs when there is a limited amount of detailed information about the project, generally less costly than other techniques. Also, it's generally less accurate. So, when we look at cost rates, we have to determine how much resources we have, so we determine resource cost rates. So, for each resource to estimate schedule activity costs. So, we have to estimate schedule activity costs. Remember, standard rates with escalation factors can be included in the contract. And also, obtaining data from commercial databases and seller published price list is another source of cost rates. Like, I can't remember it right off the top, but we used to get books out there, construction books, and somebody can leave it in my comment section. But they used to come out every year. I know Craftsman used to produce them as well, but they would have the average of all of the nationwide costs. They would have all of the nationwide costs. And that's getting there. Now they're all online. And we gather quotes. We can use those to gather quotes. We can use those to gather quotes. And they're very good. Trying to find out what those books we use to gather cost of construction projects. It's a company, and what it does, it produces different rates every year. You don't get the same book every year. In fact, I have one from 2011, and they're very RS means. That's what it is. RS means. I almost had to put it in AI to help me out, and just came right out. It's RS means. Those are books that are used to obtain data. That's the commercial database. Remember that. You may see that on a test if you want to be an estimator as well, or if you may need to use RS means. You're a contractor as well. Okay, moving on. We have bottom-up estimating. Basically, this type of estimating It's a technique and involves estimating the cost of individual work packages or individual scheduled activities with the lowest level of detail. So the cost and accuracy of bottom-up cost estimating is typically motivated by the size and complexity of the individual schedule activity or work package. Generally, activities are smaller. Or let me go back a little bit. Generally, activities with smaller associated effort. Activities with smaller associated effort increase the accuracy of the schedule activity cost estimate. So generally, activities with smaller associated effort increase the accuracy of the schedule activity cost estimates. And we have something called parametric estimating. And that's a technique that uses a statistical relationship between historical data and other variables. Example, square footage in construction. And this technique can produce higher levels of accuracy depending on the sophistication as well as the underlying resource, quantity, and cost data built into the model. So basically, a cost-related example involves multiplying the planned quantity of work to be performed by the historical cost per unit to obtain the estimated cost. Now, let me give you an example of that. If I am going to put down a concrete slab, and I'll make it easy for you, we're going to put that concrete slab down in square feet, and we're going to have a rectangular floor to start off with. And let's say we have a length of 20 feet and a width of 40 feet. Now, when I go and estimate that, I'm going to use a unit. That's what they're talking about. So I'm going to end up with square feet. So I'm going to multiply 20 feet times 40 feet, and I'm going to come up with 800 square feet. That's what they're talking about. And there are going to be items associated with the materials to place that concrete slab. Now we deal with something that's very, very important, and most of us use it today. That's project management software. So we have cost estimating software, computerized spreadsheets, and simulation and statistical tools. They're widely used to assist with cost estimating. Then we have vendor bid analysis. Other cost estimating methods include vendor bid analysis and an analysis of what the project should cost. So in cases where projects are won under competitive processes, additional cost estimating work can be required of the project team to examine the price of the individual deliverables and derive a cost that supports the final total project cost. Now, when you do any type of estimating, you're actually building the project. This is why you need to know the plans well. Now, when I mention some construction cost software, there's a lot of it out there. I know Procore is out there, and you can even do spreadsheets. In fact, when I did a concrete floor problem, I actually used a spreadsheet right here on the computer and showed you how I came up with the square footage. So you need to know math because there's also a reserve analysis. And what do I mean by that? Well, many cost estimators include reserves, also called contingency allowances, as costs, and many schedule activity cost estimates. This has the inherent problem of potentially overstating the cost estimate for the schedule activity. Cost budgeting involves aggregating the estimated cost of individual schedule activities or work packages to establish a total cost baseline for measuring project performance. Cost aggregation This is all under cost budgeting. So when we deal with cost aggregation, that's scheduled activity cost estimates are aggregated by work packages in accordance with the WBS. Now, what's WBS? That's the work breakdown schedule. Then you have your reserve analysis, and that establishes contingency reserves such as the management contingency reserve that are allowances for unplanned but potentially required changes. So such changes may result from risk identified in the risk register. Then you have a funding limit reconciliation. That's where you have large variations in the periodic expenditure of funds, which are usually undesirable for organizational operations. So therefore, the expenditure of funds is reconciled with the funding limits set by the customer or performing organization on the disbursement of funds for the project. Then we have what we call cost budgeting outputs. Now, this may be a review because I did some of this in the past, but cost is a major issue when it comes to anything that we deal with in life. We want to make sure that we're getting bang for our buck. We also have to, because in regular life, most humans don't live within their means and they don't know how to budget. But with cost budgeting, there are outputs. So for projects, you have to budget. And if you understand what I'm talking about now you might not understand the vernaculars that I'm speaking, but overall, when it comes to cost, common sense should tell you that if I can't afford a Lamborghini for $100,000 and I only make $50,000 a year, I shouldn't buy it, because if I buy it, I'm going to be broke and I'm going to be paying interest on a loan that I have to borrow. Well, this is why we track costs, and this is why we deal with the outlook of, are we going to build a project? What kind of budget are we going to have? So when we deal with outputs, we have what we call a cost baseline. And what it is, it's a time phase budget that is used against which to measure, monitor, and control overall cost performance on the project. That's exactly what it is. It's a time phase budget that is used as a basis against which to measure, monitor, and control overall cost performance on the project. Now, we also deal with what I call project funding requirements. And that's funding requirements, total and periodic. Example, they're annual or quarterly. They're derived from the cost baseline and can be established to exceed, usually by a margin to allow for either early progress or cost overruns. Funding usually occurs in incremental amounts that are not continuous, and therefore it appears as a step function. And that's what they're talking about right here. This is a step function, your funding requirements. This is exactly what they're talking about. You can see the picture. Then we deal with cost control. Cost control includes influencing the factors that create changes to the cost baseline, ensuring requested changes are agreed upon, managing the actual changes when and as they occur, assuring that potential cost overruns do not exceed the authorized funding periodically and in total for the project, monitoring cost performance to detect and understand variances from the cost baseline, recording all appropriate changes accurately against the cost baseline, preventing incorrect, inappropriate, or unapproved changes from being included in the reported cost or resource usage, informing appropriate stakeholders of approved changes, acting to bring expected cost overruns within acceptable limits. And we have our cost control inputs. And that features the cost baseline. That's the cost baseline, project funding requirements, performance reports, work performance information, approved change requests, and a project management plan. Now, under cost control tools and techniques, there's a cost change control system. And a cost change control system documented in the cost management plan defines the procedures by which the cost baseline can be changed. So we have what we call a performance measurement analysis. And the performance measurement techniques help to assess the magnitude of any variances that will invariably occur. And we have our EVT, which is our earned value technique, and it compares the cumulative value of the budgeted cost of work performed, which is earned at the original allocated budget amount, to both the budgeted cost of work scheduled, which is planned, and to the actual cost of work performed, that's actual. This technique is especially useful for cost control, resource management, and production. Now, under the cost control change system, or the cost change control system, a cost change control system, again, I just gave it to you before. We have the cost change control system documented in the cost management plan. Again, it defines the procedures by which the cost baseline, it can be changed. It includes the forms, documentation, tracking systems, and approval levels necessary for authorizing changes. We have our performance measuring analysis, which I just mentioned earlier, a slide ago. Well, those techniques help to assess the magnitude of any variances that will invariably occur. The EVT, which is your earned value technique, compares the cumulative value of the budgeted cost of work performed, again, earned at the original allocated budget amount, to both the budgeted cost of work. That's the budgeted cost of work schedule, which that's the work plan, to the actual cost of the work performed, that is actual. Again, this technique is especially useful for cost control, resource management, and of course, production. Now, we have our EVM, that's our earned values measurement. And that's a technique that involves developing these key values for each schedule activity, work package, or control account. It is a method measuring project performance by comparing the amount of work planned with what has actually been accomplished in order to determine if cost and schedule performance as planned. Now, you're going to have some acronyms. So for scheduled work, you have your budgeted cost of work schedule. That's PV, earned value, budgeted cost of work performed. Actuals, actual cost of work performed, that's AC. Authorized work, budget at completion, that's BAC. Forecasted cost, estimate at completion, EAC. Work variance, that's schedule variance, SV. Cost variance, that's CV. Completion variance is VAC, VAC. And you're going to have your variance calculation. Again, you're going to have your variance calculation. So cost variance, which is CV, that equals EV minus actual cost. So to put it all into perspective, your cost variance equals the earned value minus the actual cost. Then you have the cost variance at the end of the project, and it will be the difference between the budget at completion and the actual amount spent. So you have your formula. CV equals EV minus AC. Now, the negative value of CV would mean there is a cost overrun. And then you have your SV, that's your schedule variance. And that equals your earned value plan which is PV, schedule variance will ultimately equal zero when the project is completed because all of the planned values will have been earned. So formula is schedule variance equals earned value minus planned variance. Planned variance. So SV equals earned value minus planned variance. Again, the schedule will ultimately equal zero because all of the planned values would have been earned. Again, when you have a negative schedule variance, that also means time overrun. And you have your CPI, that's your cost performance index. Now, a CPI value less than 1.0 indicates a cost overrun of the estimates. A CPI value greater than 1.0 indicates a cost underrun of the estimates. So, to get your cost performance index, your CPI, you have to divide basically, you're dividing earned value by actual. CPI is the most commonly used cost efficiency indicator. Again, CPI equals EV divided by AC. Then you have your schedule performance index. Now, the SPI is used in addition to the schedule status to predict the completion date, and it is sometimes used in conjunction with the CPI to forecast the project completion estimates. Again, the SPI is used in addition to the schedule status to predict the completion date and is sometimes used in conjunction with the CPI to forecast the project completion estimates. So basically, SPI equals the ratio of the EV to the PV. Estimate at completion. EAC equals AC plus ETC. Well, estimate time to complete equals the revised estimate for the work remaining. And the earned value technique in its various forms is a commonly used method of performance measurement. It integrates project scope, cost, or resource, and schedule measures to help the project management team assess project performance. That's what you got right here. This is your planned value. This is your earned value. This is your actual cost. Now, again, there's some different exercises. And this is how it's done. Now, exercise 1, we have your schedule variance example. So we're given the PV at $42,000. We're given the EV at $38,000 and your AC at $48,000. We also have the BAC at $80,000. So your SV equals your EV minus PV. Now, when we take 38,000 minus 42,000, we get minus 4,000. Well, what does that mean? Now we have an overrun. So what we do, we take that SV, which is a scheduled variance, and we divide it by the PV. So we take the negative 4,000, we divide it by 42,000. We get a negative 9.5%. Hence, there is a schedule overrun of 9.5%. So we have exercise 2. CV equals EV minus AC. So for the EV, we take the same $38,000, but then we subtract $48,000, which is your budget at completion, and then we have negative $10,000. So we have to find a percent of our cost variance, and we divide that by your earned value, and we get a negative 26%. So that is a larger overrun, 26%. Then we have our Cost performance index, CPI equals EV divided by AC. 38,000 divided by 48,000 is 0.79. So what that means is for every 79 cents worth of work, let me explain it a little better. For every dollar spent, you have 79 cents worth of work done. And that's for every dollar spent. Now, it's almost 80%. You're above 0.75%. So I'd say you're 79% completed on this job. Or let me backtrack, for your cost performance, you're almost 1-to-1. But like I said, for every dollar spent, 79 cents worth of work done. Now you have your schedule performance index. That's your EV divided by your PV. 38,000 divided by 42,000 gets you 0.90. So for every $1 worth of work that was planned to be done, 90 cents worth of work has been for each done for each. So let me put it in better perspectives. For every $1 worth of work that was planned, 90 cents worth of work has been completed. And then you have your estimate at completion, variance at completion, estimate at completion, and variance at completion. So you have EAC equals BAC divided by CPI, 80,000 divided by 0.79 gives you $101,000. It's going to round it off to $101,000. However, when you go ahead and put it in the formula, you're going to get a negative number, which you're going to have your VAT. You're going to use your BAC minus your EAC. Take 80,000. That's called $101,265. Well, when you subtract $101,265 from 80,000, then you're going to get negative $21,265. That means the project will exceed the budget, and that's the planned budget. The project will exceed the planned budget by $21,265. Now, here's some other examples. I'm not going to complete them. I just did it on the last slide there, but this is what you would have to do. Know these formulas. You have your different cases right here. Here they've already done, they basically have given you all the answers right here. Here are all the formulas right here. What you come up with. I would go back, take these cases, work these numbers. You may be seeing them on the FE exam as well. You may even see them on the test if you're taking a construction cost control class. Now, something important, you have the unit cost method of estimation. And I just mentioned it to you before when I gave you that example on the slab in feet. Now, to move further, let's talk about the design technology. And anytime you have design technology for a facility that has been specified, the project can be decomposed into elements at various levels of detail for the purpose of cost estimation. So the unit cost for each element in the bill of quantities must be assessed in order to compute the total construction cost. This concept is applicable to both design estimates and bid estimates, although different elements may be selected in the decomposition. So for design estimates, again, as I mentioned to you before, for design estimates, the unit cost method is commonly used when a project is decomposed into elements at various levels of hierarchy as follows. And that's various levels of hierarchy as follows. And here we go. You have the preliminary estimates. That's the project that is being decomposed into major structural systems or production equipment items. Example, the entire floor of a building or a cooling system for a processing plant. In fact, I just gave you the entire floor of a building when I talked about the 20 by 40, which is 800 square feet for a concrete slab. Then you have your detailed estimates, and that's when the project is decomposed into components of various major systems, i.e., floor panel for a building or a heat exchanger for a cooling system. Then you have your engineer's estimates. That's when a project is decomposed into detailed items of various components as warranted by the available cost data. And this is where you can use US means or craftsmen, or you can even look at other contracts if this project is similar to what was built in the past. So, examples of detailed items are slabs and beams in a floor panel, or the piping and connections for a heat exchanger. Then we have what we call a computer cost estimate. Now, some of the common features of computer aided cost estimation software include databases for unit cost items such as worker wage rates, equipment rental, or material prices. These databases can be used for any cost estimate required. So if these rates change, cost estimates can be rapidly recomputed after the databases are updated. Now, databases of expected productivity for different component types, equipment, and of course, construction processes. Then you can import utilities from computer-aided design software for automatic quantity takeoff components. Alternatively, special user interfaces may exist to enter geometric descriptions of components to allow automatic quantity takeoff. And then you have expert utilities to send estimates to cost control and scheduling software. Now, this is very helpful to begin the management of costs during construction. Then we deal with version control to allow simulation of different construction processes. In version control, we're going to use to allow simulation of different construction processes to design changes or design changes. So version control to allow simulation of different construction processes or design changes for the purpose of tracking changes or expected costs. We have provisions for manual review, override, and editing any of the cost element resulting from the cost estimation system. And we also have flexible reporting formulas, including provisions for electronic reporting rather than simply printing cost estimates on paper. And we have, I just mentioned it before, archives of past projects to allow rapid cost estimate updating or modification for similar designs. And then we have components of project cost estimates for major projects, preliminary engineering. This is the cost to prepare the construction documents. Right of way. This is the cost to research and acquire right of way the project, including easements, include right of way for cost for stormwater management, wetland mitigation, and other outside the roadway prison. Now, DOTs usually would use right of way because they might want to add a travel lane on an existing road. They might want to build a bypass. So they're going to use the right of way. And then you have a third party, and that's an external third party. Usually it's going to be a utility or utilities and railroad adjustments. Perhaps the most difficult cost to estimate are those that are associated with third parties, such as utilities and railroads. And one thing that I can tell you, particularly with utilities, Utilities can hold up the project because utilities definitely have to be relocated, and you might have some issues with the railroad as well. And finally, using software to assist in cost management. Now, I like spreadsheets if you don't have software, but you have to know how to use spreadsheets. Why? Now, spreadsheets, I'll tell you why. They are a common tool for resource planning, cost estimating, cost budgeting, and cost control. However, many companies use more sophisticated and centralized financial application software for cost information. Project management software has many cost related features, especially enterprise PM software. Now, what you're really getting here when it comes to estimation, basically the type of contract that they were discussing with units is known as a unit cost contract. Now, there are different types of contracts. Each contract has costs associated with it. And what I did tonight was give you information on what project cost management really is. And to review what it really is, the actual definition is construction project cost management. Again, construction project cost management is the process of planning, estimating, budgeting, monitoring, and controlling project expenses from start to finish to ensure that the project stays within its financial limits. Of course, its key components include accurate initial estimates, real-time cost tracking, managing change orders, and controlling expenditures for materials, labors, and subcontractors. So effective cost management improves profitability, helps meet project deadlines, and builds a strong reputation. Again, you have your key processes, which include planning and estimating, budgeting, monitoring, controlling, and reporting. Then you have your importance and benefits. That's where you find profitability, timeliness, decision making, reputation, and then your challenges, unforeseen expenses, poor planning, inefficient communication, and siloed systems. And I've given you a pretty good breakdown on construction project cost management. If you want to be a project manager, you will get into a lot of this. Engineering economics is very important. And even if you're not a civil engineer major, if you are industrial engineers, you also get into a lot of cost management because you're going to be dealing with systems. And every project is not necessarily a construction project. You're going to have manufacturing, you're going to have optimization. And when we deal with branches of engineering, such as industrial engineering, when they deal with cost, they're talking about the whole system. Where in my field, civil engineering, we have a whole system, but we break it down into components. However, you deal with cost. And in some areas in accounting, you're going to encounter cost management when you deal with variable costs, fixed costs, direct costs, indirect costs, because you're talking about labor. So when it comes to this topic, you have business and technology combined. But overall, when it comes to any project, bottom line is you need an efficient system to track all of your costs, because in the end, you want to make sure that each and every project is completed on time and under budget. And when that happens, you're going to get more work, you're going to keep your reputation, and you're going to make profit. and it's going to keep you as a leader in the market because construction is very, very competitive. And that basically sums up everything that I talked about. But it's very important that you understand the procedures of construction cost estimate. And thank you for viewing this topic on construction project management or construction project cost management. That's construction project cost management. This was information that is very important, and I thank you for viewing this topic on construction project cost management. If you like what I just presented, please leave a comment in a comment section. Also like, share, and subscribe to this channel. Overall, it's a good topic if you are into project management. This is probably going to be on the PMP exam as well. You're going to hear terms like scheduled variance, earned value. But in the end, this information is going to help you on the FE. It's going to help you become a better project manager, and even going to help you on PMP. Again, that concludes this topic on construction project cost management. Like what I just presented, please comment, share, and subscribe. And here's where you can find me as well. We're looking for some social and political content. You can find my main channel, the 411 Talk Zone radio show, right here on YouTube. Also find the 411 Talk Zone radio show channel on X, formerly Twitter. Also find it on Rumble and Truth Social. For the QCIS channel, also find me right here on YouTube, X, formerly Twitter, and LinkedIn. Once again, thank you for viewing this content on construction project cost management, the QCIS channel. On this channel, you get a daily dose of science, technology, engineering, and math. Till next time, my name is Leon Jones. I want you all to have a wonderful and gracious evening.